Now, before we do integration and primitives, we're going to look at two approximate methods of integration, which give very close approximations to the area, but not exact. And this was the development of the topic through history. So, let's say we've got an area on a Cartesian plane that we want to find the area under. So it might be something straightforward like that. And we want to find the area between A and B. One method they looked at was dividing, instead of dividing it into rectangles, dividing it into a series of trapezia or trapeziums. That's the plural, trapezia. So that if we draw a line from A to B down there across the function f of x, you can see that instead of drawing a rectangle, that actually would give a closer approximation to the area, because that little bit that's left over there is a lot less than if we were to draw a line either that way as a rectangle or on the top. So you know what the trapezoidal rule is to find the area. Area of a trapezium, sorry, not the trapezoidal rule, but the area of a trapezium is a half times the height times the sum of the parallel sides, A plus B. And don't forget, the height has to be the perpendicular height. So in our case on the diagram, that's the perpendicular height there. So the height is the distance between A and B. That's one parallel side, that's the other parallel side, and we divide that by 2. Now if you think about it, x there, this parallel side, I'll call it x and y, that's f of A, and this one up here is f of B, the two lines there. Okay, so we know that. What about if, like the rectangles, we now divide it into two trapezia? So up to the function itself again, there's 1, there's 2. So this error is just decreasing each time. Okay, there's only a little bit there and a little bit there compared to the first lot. So now we've got to find the area of the two trapezia. So same formula, obviously. Now if you think about it, this height here, let's say we call that C, f of C is going to be used twice. It's going to be used as one side of this first trapezium and then this trapezium here. So only x and y are being used once. Well, let's see what happens if we keep going. I'll halve both of those again, join up the trapezia, so the area at the top is really now very small. And let's see what happens again. Well, there's the first trapezia. So that length and that length is going to be used. We'll call that D and we'll call that E. So it's f of D and f of E in here if we can. So f of A and f of D are going to be used, f of D and f of C are going to be used, f of C and f of E are going to be used, f of E and f of B are going to be used. So you can see what's happening. The internal ones are being doubled, and the x and the y, the outer ones, first and the last, are only being used once. So if we extrapolate this to the general area under a curve here for the, and it's called the trapezoidal rule, we probably should write that. Trapezoidal rule, meaning summing these trapezia. Colloquially, the area equals h divided by 2, which we know is in a normal area rule for trapezium. And then it's, as we just had a look at, it's the first plus the last, and by that I mean the y values. The first y value, so when you sub in y0, what you get for this function, that's f of x. So it's the first plus the last. They're only used once. Plus, and then how many did we say it was of everyone else? That's right, 2. Everything's doubled. So we're going to use y1 twice, y2 twice, because it's the sides of two different trapezia. So colloquially, it's plus 2 of the rest. Now, of course, we're not going to write the rule colloquially. So let's write it correctly. It's h on 2 into y0, which means the y value at the 0 point there, plus yn, the very last one, is the general term, hence the dots here. We don't know how many trapezia we're going to have a look at. Plus 2 lots of, and then we've got y1 plus y2 plus y3 plus down to, now what's this last one here? I haven't drawn it in. What would that one be? Because we've already included the n, that's in the first bit here. The one before that, that's right, is y n minus 1. So that's our trapezoidal rule. And if you're wondering what the h is normally height. Don't get confused though. In this case, as we just saw, height's the perpendicular in any shape, where the two sides are perpendicular. Well, they're all the perpendiculars there. So the height is actually this distance between these x values here. How do we find that if we're not sure, or if it's a written question and we're not actually told? Well, this is how we find it. H equals b minus a divided by n. And that means b is the last value, a is the first value, and n is the number of number. Oh, I'm going to rewrite that. That's shocking. N is the number of trapezia. Next line. Okay, so think about it. If this was 1 and this was 5 and we had 4 trapezia in the middle, then it's 5 minus 1 is 4 divided by 4. So you'd be going up by ones. If that was 1, it'd be 2, 3, 4, and the last one would be 5. We'll see how it works in a minute.